Yeah, we offered you those numbers and we'll show them to you again. Colorado State expecting El Nino to drive the season this year. But in terms of the number for named storms, it's one less than the average. It's one less when you look in the hurricanes department, even with major hurricanes, one less than the 30-year long-term average. So yes, you can say it looks like they're predicting a below average season. Last time they did that was 2023, but warm sea surface temperatures that year allowed for many more storms to form. And that's the thing, whenever we look at predictions and outlooks from Colorado State University and other entities, there are experts behind and scientists behind these methods. So it's important to approach this thing with that full knowledge that it's not just about, all right, what are the numbers? A lot of times it's that why, asking that question always to understand and get a better grasp on things. One thing we know for certain, I guess we'll never be certain, but there's a really high chance that we develop an El Nino along the equatorial Pacific waters. Those are right near the equator, so the strong El Nino looking likely, and here's one of those indications as works up. That's just one of many factors, and you consider how many different variables go into a hurricane season, you can understand how there is sometimes some nuance. I'll quickly work through these, the other factors that CSU highlighted, and we'll be talking about it throughout the day. Hostile upper level winds, Atlantic water temperatures not as warm, and then finally, similar seasons had fewer storms. So those key bullet points are the reasons why we have those numbers from CSU.
All right, and speaking of, we have Fox Weather Hurricane Specialist Bryan Norcross joining us live from the National Tropical Weather Conference in South Padre Island, Texas this morning. That's where the numbers were just announced. You'll notice Bryan is not alone. He's also joined by meteorologist and senior Colorado State research scientist Dr. Phil Klotzbach. Phil leading the team of those numbers from CSU University. But Bryan, I'll let you take it away as we begin to really comb through some of the outlook this morning.
All right, Marissa, thanks very much. Phil, excellent presentation this morning. You know, we've been talking so much about this El Nino because the forecasts have been for El Nino. The water, the ocean looks like it's going to generate an El Nino. So when you came in with below normal statistics, that wasn't a surprise, I guess. But we've seen, I just want to kind of temper everybody's expectations here, because we've seen this before, right, where it has changed. Like in the spring, things are still a little dicey. It's not like a slam dunk situation.
Yeah, that's correct. So right now we are anticipating a robust El Nino this summer and fall, which is the main reason why we came out with a forecast for a little bit below normal season with 13 storms, 6 hurricanes, and 2 major hurricanes. But there is a lot of uncertainty. We have this phenomenon called the springtime predictability barrier for El Nino, and obviously we're right in the middle of the spring. And so basically, like, small changes in the winds over the tropical Pacific can make big differences in how robust this El Nino is. And if you look at the forecast from the different models, some models are really aggressive, saying it's going to be a really, really strong event and come on really quickly. Others are saying maybe a little weaker, take a little longer. And exactly how it comes on is a big driver of, you know, how much storm activity we end up getting in 2026.
We've been talking about this potential super typhoon in the Western Pacific and also those storms in the Southern Pacific, and how that's really put a big burst of energy kind of pushing toward an El Nino. But it's not necessarily for sure that it's going to end up that way, right? It's not just that simple as, okay, once you get one of these bursts of energy that it converts into a super El Nino right away.
That's correct, yeah. So we did, as you mentioned, we did just have a really robust, what we call westerly wind burst. So the winds came pretty strong actually out of the west, driving this warm water, typically by Indonesia, further towards the east, which should cause some anomalous warming pretty quickly. But do we get another one? That's kind of the question, you know, do we get another really robust westerly wind event? If we do, then probably yes, we would head over to a really robust El Nino quickly. But there's been years where you get one and then you just don't get a follow-up one. And so I think that's kind of one of the big questions that we're obviously kind of have to wait and see how things play out.
Yeah, how about in the Atlantic? In the tropical Atlantic, the water is not especially warm this year, but it is really warm just north of there, right? Does that, what does that tell you? Does that part of why you kept the number numbers relatively low because the tropical Atlantic is, it's not cold, but it's not super warm.
Yeah, so the tropical Atlantic, what we call like the Atlantic's main development region where most of the hurricanes form, is about average right now. If you look in the subtropical Atlantic and the eastern Atlantic, right there the waters are still fairly cool as well. Typically, if the waters there are really warm, that will tend to cause basically lower pressure in the subtropics, which relates to weaker winds blowing across the Atlantic, which causes the tropical Atlantic, the main development region, to warm really quickly. Right now, we don't see signs that that's what's going to occur. So that's one of the reasons why we also kept the numbers a little bit below normal, because we do think, probably pretty healthy El Nino. Right now, the Atlantic, our best estimate is probably a little warmer than normal, but there's probably even honestly more uncertainty in that than there is in the El Nino, just given the Atlantic prediction skill is fairly low.
Earlier we were talking about, and in fact Marissa asked the question about AI. Obviously AI was a big topic of conversation last year with the Google DeepMind model, with the forecasting of the storms, and you dabbled in it for your seasonal forecast. And I said I think that AI is going to be a more significant part of the seasonal forecasting in the future. How do you see AI coming into it? Because this is a big data problem that you're trying to do here, trying to analyze what's going on all around the world, right?
Yeah, that's correct. So, we are starting to incorporate AI machine learning models into our seasonal forecast. There's probably some variability in the hurricane season that we can't get at with kind of our more traditional modeling approaches. So we're starting to incorporate that in, and we'll be using more and more of that technology over the next few years. One is, as those models get more data points, they're going to get better. And obviously, as we get more experience running them, we can kind of see what works with them, what doesn't work, and hopefully try to fine tune the next generation of those as well.
Yeah, and you run them on past seasons so you can see how they could work, based on what we know, right? All right, Stephen and Marissa, it's a big day here at the conference every year. Phil Klotzbach makes this announcement that gets now broadcast worldwide, of course, and it's a pleasure. We've been working together here since Phil was a kid, and Dr. Bill Gray introduced me. He said, "This is my new guy. This is the guy that's going to take over here." Well, those many years ago.
And it's crazy that we're talking about these outlooks that have been released from Colorado State University for more than 40 years. It might be too nuanced, Brian, but we were told that we've got a couple of minutes or a minute or so. Those westerly wind bursts, this is more in the near term. Any idea what causes a westerly wind burst? I'm sure it's near impossible to predict.
Okay, let me ask Phil about that. A westerly wind burst was the question from Stephen. What causes westerly wind bursts? We know that sometimes we get a typhoon out there, or a cyclone, they're called in the Southern Pacific, and together they create it, right? Are there other mechanisms that cause westerly wind bursts that can move the warm water over to the Eastern Pacific?
Yeah, so sometimes, as you mentioned, it is tropical or typhoons, cyclones that can cause those. You can also get them just from kind of like your variability that goes on over the course of shorter time scales. We call it like the Matt and Julian oscillation. Basically can alter the winds in such a way that you'll tend to get more low-level westerly winds. So that was probably one of the big drivers of the recent westerly wind bursts that we had, in addition to a cyclone in the southern hemisphere, kind of helping add it. Sometimes if you get cyclones on both sides of the equator at the same time, that can generate a really robust one. Other times, if you just get one really, really low latitude strong cyclone, you think about a cyclone in the northern hemisphere on its southern extent, it's going to be winds out of the west. That can also cause a very significant westerly wind burst.
Yeah, there's a system developing or heading in the general direction of Guam, which is forecast by some of the models to be a super typhoon when it gets there, and be a large super typhoon. So on the back end of that, that's pushing water off right toward the Eastern Pacific. So yeah, multiple mechanisms, but it is really interesting. We were looking at it, I think it was last week, as a matter of fact, the developing typhoons and systems in the Western Pacific, and whether that effect continues, because we've got a good ways to go to the beginning of hurricane season, and all this, and then we get to October. If the El Nino peaks in October, that could end the season early, right?
That's correct. So typically El Nino, one of the big drivers of why it matters is because of how it changes levels of vertical wind shear, and vertical wind shear typically is what ends your season. And so in El Nino years, typically it tends to end your season early, especially like the strong storms, say, coming out of the Caribbean. Since typically your strong storms late tend to form in the Caribbean, the El Nino tends to kind of put an end to those even earlier than normal.
All right, great.
Yep.
So Stephen and Marissa, Phil says plan your vacation for October, and it should be fine.
Brian was in my
he
mind.
really
because
is.
I was like, all right, late August, September. Well, no, yeah, but it's true.
And sometimes you can find really good deals for
yeah,
that part, you
yeah.
know, for that part of the basin. Appreciate you both. And a reminder for
Fascinating
CSU,
combo, yeah.
we're going to get updates to the forecast throughout the season. It's June, July, and August, so we'll be also waiting for those as things develop. Thank you, Fox Weather Hurricane Specialist Bryan Norcross. And we also have Dr. Philip Klotzbach there with Colorado State University. Thank you both.